In question 1 part A, we are given two functions, f of x equal 2 minus x and g of x equal 2 raised to the power of x. Define the term injective function and state whether f of x is an injective function. So the term injective function, it simply means injective is simply a one-to-one function. Another way of seeing the same thing is a function is injective when each element in the domain is mapped onto a unique element in the codomain. State whether f of x is an injective function. Yes, f of x is injective since, and the reason, if we let f of a equal f of b, what will happen is that f of a is 2 minus a, replacing x with a, so 2 minus a, and f of b will be 2 minus b, replacing x with b, and if we subtract 2 from both sides, we're left with minus a equal minus b, and if we divide both sides by minus 1, then a is equal to b. So if f of a equal f of b, then a should be equal to b. That's how we prove if a function is injective. Let's move on to part 2. G f of x equal to 16. Solve for x. So we need to find g f of x. So g f of x, g f of x is 2 minus x. So g f of x is g of 2 minus x. We're told it's equal to 16. So we substitute 2 minus x into g, meaning replace the x with the terms in the bracket 2 minus x. So 2 of x becomes 2 to the power of 2 minus x. That's equal to 16. Now, we have an exponential equation here, so we're going to rewrite 16 with base 2, and 16 can be written as 2 to the power of 4. So since the bases are equal, we can equate the powers. Therefore, 2 minus x is equal to 4. And we solve. So in solving this equation, we can just rearrange a group in here. So minus x, if I group minus x on the right, it's positive. We have 2. If I group 4 on the left, it's negative. So 2 minus 4, that's negative 2. So x equal to negative 2. In part B, determine the range of values of x for which the quadratic inequality 3x squared plus 8x less than or equal to 3. And we're told x is a real number. So we have a quadratic, so we'll group all the terms on the left hand side. Minus 3, we have 0 on the right, so we can either use the quadratic formula or we could factorize. Let's factorize. So factorizing, I'm using the AC method. So AC, that's 3 times minus 3, that's negative 9. So we need two numbers that multiply to give minus 9 and add to give positive 8, that's 9 and minus 1. So we rewrite the middle term as positive 9x minus 1x, and then we restate the rest of the terms. So we factor by a group. The first group, factor out 3x. In the bracket we have x plus 3. Second group, factor out minus 1. In the bracket, same bracket, we expect x plus 3 less than or equal to 0. So our common bracket is x plus 3, and outside the bracket we have 3x minus 1 less than or equal to 0. And to get our critical values, we can equate the brackets to 0. So if we equate x plus 3 to 0, we get x equal negative 3. So critical values, we equate x plus 3 to 0, we get x equal to negative 3, and we equate 3x minus 1 to 0, we get 3x equal to 1, divide both sides by 3, x equal to 1/3, and since it's less than, when it's less than, x is between the critical values. So therefore, the solution is x is between, so it's less than the larger value, so less than 1/3, but greater than the smaller value, which is negative 3. So that's our solution. Let's move on. Part C. A board whose length is 258 centimeters is cut into 12 pieces. Calculate the length of the first piece of board, assuming that the lengths are in arithmetic progression and the sum of the first 3 pieces of board is 2d. So we have an arithmetic progression here, 258, 12 pieces. So we can formulate equations from both sentences. So we know for the arithmetic progression, the sum of the first n terms is n over 2 into 2a plus n minus 1d. And that's the summation formula. And the n term formula, a, so the n term, a subscript n is a plus n minus 1 times d. So those are the two formulas we use for the arithmetic progression. So a board whose length is 258 centimeters is cut into 12 pieces. So we can formulate an equation from this. The sum, we know the sum, so the board is cut, the board is 258, so the sum of the pieces will be equal to 258. And of course, it's 12 pieces, so the sum must be 258. And n is a number of terms, 12 pieces, so n would be 12. So we'll put these in the summation formula. N, 12 over 12 divided by 2, that's 6 into what we have in the bracket. We'll have 2a plus, and if n is 12, the number of terms, the number of pieces, 12 minus 1, n minus 1 will be 12 minus 1, 12 minus 1, that's 11, that's 11d, and we can reduce this equation by dividing both sides by 6, so we can divide both sides by 6. We'll end up with 258 divided by 6, that's 43, 6 into itself, leaving 1, so it's just 2a plus 11d. So that's one equation, and that's from the first sentence. In the second sentence, we're told that the sum of the first 3 pieces of board is 24 centimeters. Alright, so sum of the first 3 pieces, so the first piece, let's call the first piece A. The second piece will be A plus the common difference. So let me put it another way, just to be clear. I'm going to call the first piece A subscript 1, second piece A subscript 2, third piece A subscript 3 equal to, we're told the sum of the first 3 pieces 24, so equal to 24. Now A subscript 1, let's call that A. And if you think about it, you're replacing in the formula here, if you replace n with 1, it's just a plus 0, which is just a. If you replace n with 2, it's a plus 2 minus 1, that's 1. That's 1d. And the third piece, if you replace a with n, with 3, is a plus 3 minus 1, that's 2d. So the third piece is a plus 2d equal to 24. If we group all the a terms, we have 3a plus 3d equal to 24. And of course, we can reduce this equation by dividing all the terms by positive 3. Divide by 3 just to reduce it. We'll get a plus d, and 24 divided by 3, that's 8. So we have a pair of simultaneous equation. A plus d equal to 8. Same as saying 8 equal to a plus d. And we can use elimination method to solve this. To solve this, we can just multiply the second equation by 2. So we'll end up with 43 equal to 2a plus 11d. Multiply the second equation by 2. We'll get 16 equal to 2a plus 2d. And if we can subtract, so 43 minus 16, that's 27. 2a minus 2a, leave 0. 11 minus 2, that's 9d. If we divide both sides by 9, then d is equal to 27 divided by 9, that's positive 3. So d is equal to 3. And if d is equal to 3, we can substitute it in any one of the equation. For substituting this equation here, if d is 3, it means that a plus 3 is equal to 8, which means subtract 3 from both sides. It means a is equal to 5. And you can test your answer. The question says that the sum of the first 3 pieces must be 24 centimeters. So if the first piece is 8, these 3, so the second piece would be 5 plus 3, that's 8. And the third piece will be 8 plus 3, that's 11. The question says that if we add all these first 3 pieces, we should get 24. So 5 and 8, that's 13, 13 and 11. That's 24, so the answer checks out perfectly. In question 2, part A, we are given a function f of x. We are told that x plus 1 is a factor. Show that a is equal to 6. So if x plus 1 is a factor, change the sign of the 1. It means that f of minus 1 is equal to 0. 0 means there's no remainder. So we're going to replace x everywhere with minus 1. So minus x cubed is minus 1 all cubed, replacing x with negative 1, plus a. X squared becomes a times minus 1 squared. Minus 5x becomes minus 5 times minus 1, minus 12 equal to 0. So negative 1 to the power of 3, that's negative 1, times negative, that's positive 1. Negative 1 squared, that's positive 1, so that's 1a. Negative 5 times negative 1, that's positive 5, minus 12 equal to 0. So I just group all the constants on the right hand side. Group negative 12 on the right is positive 12. Group positive 5 and positive 1. We get negative 5 and minus 1. So a is equal to 12 minus 5 minus 1. That's 6. So we have shown that. Hence or otherwise, determine the other two factors of a function. So we know, let's rewrite the function. So f of x equal to minus x cubed. We now know that a is 6. So ax squared is now 6x squared minus 5x minus 12. Now we know that x plus 1 is a factor. So to get the other factor, we can divide. We can use either synthetic division or long division. I'll be using synthetic division. So I'm going to divide x plus 1 to get the rest of the factors. So we have x plus 1. So synthetic, what we do is, look at L shape here. Since we're dividing by x plus 1, we'll change the sign of the 1, that's minus 1. Inside the L, we'll put the coefficients of the function, so minus 1x cubed, 6x squared, minus 5, and minus 12. So we'll bring down the first value. It's minus 1. So we multiply the value outside. Minus 1 times minus 1, that's positive 1. Then we add 6 plus 1, that's 7. Then we multiply minus 1 times 7, that's minus 7. We add again, so it's just repeated multiplication and addition. We are always multiplying by the value outside here. So minus 5 plus minus 7, that's minus 12. We multiply minus 1 times minus 12, that's positive 12. And finally, add again, negative 12 plus 12, that's 0. Now this final value is always the remainder, which we expect since x plus 1 is a factor. We don't expect to have a remainder. Alright, so these that are left would be the coefficient of the quadratic, the quotient. So therefore, what we're claiming is that x plus 1 divided into the function f of x would leave us with minus x squared, minus 1x squared, positive 7x, and negative 12. So to get the other two factors, we can even factorize the quotient further. So let's factorize this further. So factorizing negative x squared plus 7x minus 12. Now I think using the AC method, AC is positive 12. So we need two numbers that multiply to give positive 12 and add to give positive 7. That's 4 and 3, right? So negative x squared plus 4x plus 3x minus 12. Alright, so if we factor by groups, factor out minus x. In the bracket, we'll have x minus 4. In the other bracket, factor out positive 3. We'll have x minus 4. So factorize, we end up with x minus 4 is a common bracket. And in the other bracket, we have negative x plus 3, or 3 minus x. So these are our other two factors, alright? So other two factors are x minus 4 and 3 minus x, which can also be written as minus x plus 3. Part B, solve the equation root 2 cos theta plus pi over 3 is equal to 1, where theta is between pi and minus pi. So right away we can just divide both sides by root 2. So what we'll have is root 2 cancel itself, so we're left with cos theta plus pi over 3 is equal to 1 over root 2. So theta plus pi over 3 is cos inverse 1 over root 2, and cos inverse 1 over root 2, that's, well, in degrees 45 degrees, but we want it in radians. So in radians, 45 degrees is equivalent to pi over 4. But remember, cos is positive in the first, so all science teachers are crazy. So cos is positive in the first quadrant and the final quadrant. Alright, in this quadrant, the angle would be negative pi over 4. So what we have is theta plus pi over 3, and we can check it. We're seeing that cos of pi over 4. Cos 45 will give you 1 over root 2. Also, cos of negative pi over 4 will also give you 1 over root 2. Alright, so that's why we have pi over 4 or negative pi over 4. Both solutions. Alright, so theta plus pi over 3 is pi over 4. Or theta plus pi over 3 could also be negative pi over 4. So to solve for theta, we can group everything on the right hand side. So that's pi over 4 minus pi over 3, which is negative pi over 12. Here we have minus pi over 4. Let's group everything on the right hand side. Minus pi over 3. That's minus 7 pi over 12. So part C of question 2. Jack buys 3 kg of apples, 4 kg of oranges, 2 kg of pears, and so on. Jill buys 8 kg of apples, 6 kg of oranges, 3 kg of pears, and so on. Mary buys again apple, oranges, pears for a total of 28. Using Cramer's rule, or otherwise, calculate the unit cost of a kilogram of apples. Alright, so we can let X represent the cost of apples. We can let Y represent the cost of oranges. And we can let Z represent the cost of pears. So formulate a system of equations. So it will be 3x plus 4y plus 2z equal to 25. And then for Jill, it's 8 apples, so 8x plus 6 oranges plus 6y plus 3 kilogram of pears, that's 3z. Total is 48. And for Mary, that's 2x plus 3y plus 4z equal to 28. So we can use Cramer's rule to find the value of x, since we only want for apples. Alright, so the value of x would be equal to determinant of the matrix AX divided by the determinant of the matrix A. Now let's find the determinant for the matrix A. Now the matrix A, determinant for the matrix A will be determinant for all the values on the left hand side, the coefficients here. So A will be 342, 863, and 234. So we can find the determinant of A using the cofactor method. So we take the first term, we take the first value here in the matrix, and we'll delete all the elements in the first row, all the elements in the first column. So that's 3 times 6, 3, 3, 4 minus, then we take the 4 now, and for the 4 we delete all the elements in the row it's in, that's and all the elements in the column is in. So we're left with the cofactor of 4, that's 8, 3, 2, 4. Alternating the signs as we go along. So next, the 2. So to take the cofactor of 2, we delete everything in the row it's in, everything that the from the column it's in, And we're left with 8623. Alright, so in calculating now we need to, so we have A, determinant of A, so it's 3 times, I'll cross multiply and subtract, so 3 times, what is 6 times 4, that's 24, minus 3 is 9, for the negative 4, cross multiply and subtract, we have 8 times 4, 32, minus 2 times 3, 6, plus 2, cross multiply and subtract, we have 3 times 8, 24, minus 2 times 6, 12. And if we enter all of this in our calculator, we'll get negative 35. So the determinant of A is negative 35. So in this formula, for calculating x, the denominator will be negative 35. Now we need to find the matrix AX. Now to get the matrix AX, all we need to do is to replace, so the determinant of AX, to get AX, we simply replace all the x coefficients, that's these x coefficients, all the x coefficients with the values on the right. So it's 25, 48, 28, and we put back all the other coefficients, so 4, 6, 3, and 2, 3, 4. Let's find this determinant now. Alright, so 25, and the cofactor of 25, actually again, you cross out all the values in the row, values in the column, you're left with the cofactor of 25, that's 6, 3, 3, 4, change sign, so minus 4, the cofactor of 4 will be 48, so cross out all the columns in, all the rows in, so we're left with 48, 3, 28, 4, and then the next element in the top row is 2, so 2, and the cofactor of 2, cross out the row, and the column that the 2 is in, so you're left with 48, 6, 28, 3. And to calculate this determinant of AX, so it's 25 into 6 times 4, which is 24, minus 3 times 3, that's 9, minus 4 into 4 times 48, which is 192, minus 28 times 3, which is 84. And the final, plus 2 into 3 times 48, which is 144, minus 6 times 28, which is 168. And this works out to give the determinant of AX. Let's put everything in our calculator, and we get negative 105. So the determinant of AX is 105, and earlier we found the determinant of A to be negative 35. So X will be divided through, we get positive 3. So to answer our question, alright, the unit cost for a kilogram of apples is $3. So unit cost for 1 kilogram of apples is $3. Now on to the third question. The stem and leaf plot below give the scores of several students who took an English exam. The maximum score for the exam was 80, so we can see the high score here is 79. Lowest score here is 17. Determine the median score. So to get the median score, we need to find the median position. So the median position, that's the middle number. Can I get that using the formula n plus 1 divided by 2, where n is the number of values. If we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there's 21 numbers. So if we add 21 and 1 and divide by 2, that's 22 divided by 2, that's 11. So the median number is the 11th number. So the median is not 11. The median number, this formula gives the position of the median, which is the 11th number. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11th number is 45. So the median score is 45. Calculate the interquartile range. So let's get the positions now for the. So the interquartile range is upper quartile minus lower quartile. Upper quartile we can call it Q3. Lower quartile we can call it Q1. And again we have formulas for Q3 and Q1 for the upper quartile. So let me do the lower quartile first. The lower quartile, also called Q1, is n plus 1 over 4. And by the way, this is formula is for the position. Alright, so n, we already know n is 21, or what, 21 values. So 21 plus 1 divided by 4, that's 22 divided by 4, which is 5.5. So 5.5 is between the 5th and the 6th number. So 1, 2, 3, 4, 5, 6. So the median, the lower quartile fall between 36 and 39. So to get Q1, we add 36 and 39 divided by 2. Add them, we get 75. 75 divided by 2 is 37.5. So the lower quartile is 37.5. Now let's find the upper quartile. We call it Q3. And the formula we're going to use for Q3 is 3 into n plus 1 over 4. And again, and by the way, this formula position is position of Q3. So we know n plus 1 is 21 plus 1. That's 3 times 22 divided by 4. That's 16.5. Doesn't mean Q3 is 16.5. It means the position of Q3 is between the 16th and the 17th number. Alright, so Q3, we know 45 was the 11th number. So 12, 13, 14, 15, 16, 17. Alright, so the upper quartile is average of 60 and 62. The 16th and the 17th number divided by 2, that's 61. So Q3 upper quartile is 61 and lower quartile is 37.5. So the interquartile is upper quartile minus lower quartile, so it's 61 minus 37.5, and that gives us 23.5. Sketch a box and a whisker diagram to represent the data in the stem and leaf plot on page 8. Alright, so we need to show 5 numbers. We need to show 5 values. The lowest value, the highest value in the box and whisker plot. So we have a box, and in the box we should be showing the quartiles. So the lowest number at the far end in the data set, the lowest number was 17, the highest number 79. The lowest number 17, highest number was 79. So 17, 79, and we have the quartiles in the box. the median was 45. The median was 45. The upper quartile, so here you should have Q1, Q2 is the median, Q3 is the upper quartile. Alright, the Q1, the lower quartile, were found to be 37.5 and upper quartile was 61. So 37.5 and 61. So that's our sketch of our stem and leaf, and we're asked to state the shape of the distribution drawn. Alright, so notice the median is closer to the lower quartile. Alright, so we say the shape is positively skewed. Alright, so it's positively skewed since Q2 is closer to Q1. So Q2 is the median, it's closer to Q1, the lower quartile. So we say it's positively skewed. It's closer to Q1 than to Q3. Let's move on. Part B. The manager of a call center has developed a probability distribution for the number of interruptions per day, X, which is a discrete random variable, and we can see the distribution table below. Calculate the value of the constant N. Now we know that the sum of the probabilities must be equal to 1. So when we add all these values up to 0.2, all the probability values, 0.3 plus N plus 0.25 plus 0.2 must be equal to 1. If we add all the values here, 0.1, 0.3, that's 0.5, and 0.25, that's 0.75, and 0.2, that's 0.95. So 0.95 plus N must be equal to 1. Solve for N, we can subtract 0.95 from both sides. So N equal to 0.05. So the value of N is 0.05. Determine the expected number of interruptions per day. So the expected number of interruptions, X represents the number of interruptions, is the sum of X times the probability of X equal to X. So multiply the X times the probability. So 1 times 0.2 plus 2 times 0.3 and so on up to 5 times 0.2. So 1 times 0.2, that's 0.2, plus 2 times 0.3, that's 0.6, plus 3 times 0.05, that's 0.15, plus 4 times 0.25, that's 1, plus 5 times 0.2, that's also 1. So add all of these values, 1 and 1, 2, 0.2 and 0.6, that's 0.8, so 2.8 plus 0.15, that's 2.95. Next, we're out to find the variance. So the variance of X is E of X squared minus E of X all squared. Now we already found E of X. Which was 2.95. So E of X is 2.95. So we have a second part there. What we need to find now is E of X squared. Now E of X squared, let's work out E of X squared up here. E of X squared is equal to the sum of X squared times the probabilities. E of X squared is X squared times the probabilities. Now this is X, so X squared, we just square the X values. So X squared will be 1 squared 1, 2 squared 4, 3 squared 9, 16, 5 squared 25. Alright, so get E of X squared, multiply all the X squared values by the probabilities. So it's 1 times 0.2, that's 0.2, plus 4 times 0.3, That's 1.2 plus 9 times 0.05. That's 0.45 plus 16 times 0.25. That's 4 plus 25 times 0.2. That's 5. So we add all of these values and we get 10.85. So e of x squared is 10.85. So what we have here, e of x squared, that's 10.85. So what we have is 10.85 minus 2.95 all square. That's 2.15. The variance is 2.15. Let's move now to question 4. An HR talent manager wishes to select 20 interviewees from among 500 applicants for internship positions in an organization. Complete the table below by writing appropriate sampling method for the descriptions. Alright, so description 1. Select equal numbers of male and female interviewees, even though they are twice as many female applicants as male applicants. So since we want both genders represented equally, that's an example of stratified sampling. Group the applicants by age and select interviewees at random from within each group in proportion to the number of applicants who make up that group. So again, earlier we're selecting by gender. Now we are selecting by age. That's also stratified. So we make sure all the age groups are represented. Stratified sampling. And the final one, assign a unit number from 1 to 500 to each applicant and use random numbers to select the interviewees. So this is what we call simple random. A simple random sampling method. Alright, continue. A box contains 3 red balls, marbles, 3 red, 4 blue, 6 white, 7 yellow marbles. A sample of 6 marbles is taken without replacement from the box. The number of ways of selecting the 6 marbles. So the number of ways would be equal to, so let's see, so 3 and 4, 7, 7 and 6, 13, 13 and 7, 20. So we have 20 marbles, and we're asked to choose 6. You can enter that in a calculator. So 20 choose 6 is equal to 38,760 ways. So in part 2, if no yellow marbles are chosen, show that the probability of obtaining 6 marbles is approximately 0.044. Alright? So no yellow marbles are shown. Now let's go back to the thing. So we have 7 yellow marbles. So if no yellow marbles are shown, when it means we're selecting from these 13 marbles. Alright? So number of ways of choosing no yellow marbles. So number of ways of choosing no yellow marbles, it means that we're choosing from the 13, choosing the 6 from those 13, alright? So number of ways of choosing no yellow marbles would be 13, and we're choosing 6 from the 13, and we can just enter that in our calculator. 13 choose 6, that's 1,716. So the probability of obtaining 6 marbles where none of them is yellow, alright, is the probability of no yellow marbles over the total. So it's number of ways of no yellow marbles. So no yellow over the grand total. We worked out earlier. The grand total was, number of ways of selecting 6 marbles was 38,760. And the numerator, the number of ways of choosing no yellow marbles, will be 1716. And that to 2 decimal places is 0.044, as we're asked to show. And the third, calculate the probability that exactly 1 red marble, 1 blue marble, and 2 white marbles, and 2 yellow marbles are chosen. So if you remember, how many red marbles did we have? So we had 3 red marble, 4 blue, 6 white, 7 yellow. So we have 3 red marble, 4 blue, 6 white, and we had 7 yellows. Alright? So the probability, so the number of ways of choosing this combination number of ways of choosing 3 red, well, 1 red, number of ways of selecting, number of ways of choosing 1 red, 1 blue, 2 white, 2 yellow is, so we have 3 red, so it's 3 choose 1. And we multiply since and. You want all the events to happen, to occur together, right? So use and not or. So 1 blue, so we had 4 blue, so 4 blue choose 1 times 2 white. We had 6 white in total, so it's 6 white choose 2. And we have 2 yellows, so it's, well, we had 7 yellows, now we're choosing 2, so 7 choose 2. And we can do that in our calculator. We get 3 choose 1, that's 3. 4 choose 1, that's 4. 6 choose 2. That's 5. And 7 choose 2, that's 21. That gives us 3,780. So the probability that we have this combination would be 3,780 over the grand total, which was 38,760. That was the first thing we calculated, and we should end up with 0.098. Part C, 10 students had 2 maths tests, 1 multiple choice and 1 essay. So the multiple choice is above here, and the essay scores are here. Their marks are recorded, and we can show the table there. Determine the estimated linear regression line of y on x in the form y equal a plus bx. So the formula sheet gives us these formulas. Let me just write them out. The formula for b is n times the sum of xy minus sum of x times sum of y over n times the sum of x squared minus sum of x all square. So n is the number of pairs of values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at 10 students, we're comparing there's 2 scores. So n, 10 times sum of xy, that's 3733, 3733, minus sum of x times sum of y, sum of x, that's 165, times sum of y, that's 191, all over n times sum of x squared, that's 3327, minus sum of x all square, so that's 165 all square. And we can just enter this in our calculator, and we should get 0.962 if I'm using 3 decimal places. Now the a, we also have a formula for a. The formula sheet gives us a is equal to the sum of y minus b times the sum of x over n, and sum of y, That's 191 minus b. We have 0.962 for b. So it's important that you find the value of b before you can find the value of a. Okay, you need b to get a. So b is 0.962 times sum of x, which is 165 over n, and n is 10. And we enter this in our calculator. And for a, we get 3.227. So the regression line, y equal a plus bx, we just substitute those. So y equal a plus bx, so y equal to a, and a is 3.227 plus bx, and b is 0.962 x. So that's our regression line for y using the formula. Alright, so a student writes the multiple choice test and scores 25 marks, but is absent from the essay test. Use your regression line found in C to estimate an estimate for the mark of the student. So the regression line is y equal to 3.227 plus 0.962x. So we are told that this multiple choice is 25, and the multiple choice score is what it represents x. So to get the value of the essay test score, you will substitute the x value, and we're told that x is 25, and that's exactly why we use this line to make estimates. So 0.962 times x, and x is 25. Alright, so put that in your calculator, and we get 27.78 approximately. Part 3, interpret the value of the correlation coefficient between multiple choice scores and test marks if it's given as 0.85. So if the correlation coefficient R is 0.85, that's a very strong correlation. This is how we say this interpretation, a strong, positive correlation between multiple choice and essay tests, alright? Between multiple choice and essay test marks. Alright, let's move on now to question. Now in question 5, we're given a piecewise function, and we're asked to determine whether or not the function is continuous at x equal to 1. So the function, notice f of 1 is equal to 4, and the limit of f of x as x approaches 1 is equal to, so not equal to 1 means it could be greater than 1 or less than 1. Either we are approaching 1 from both directions on the number line. So you substitute 1, so we have 1 square minus 1, that's 1 minus 1, 0. So notice the limit of the function as x approaches 1 is not equal to f of 1. And for the function to be continuous at 1, they must be equal. So therefore, the function f of x is not continuous. So f of x is not continuous at x equal to 1. Part B, so our function g, calculate the x coordinates of the stationary points of the function g of x. So at stationary points, g of x, well, g prime x, the derivative must be equal to 0. So differentiate the function here, multiply by the x power, subtract 1 from the power. So 3x squared multiply minus 8x, multiply and subtract 1. Differentiate negative 3x, that's negative 3. Differentiate 5, for any constant you get 0. So we're using the AC method to factorize and solve. So AC is negative 8. We need two numbers that multiply to give, well, AC is negative 9, sorry, negative 9. 3 times negative 3. We need two numbers that multiply to give negative 9 and add to give negative 8. That's negative 9 and positive 1. So we're going to rewrite the middle term as minus 9x plus 1x minus 3 equal to 0. Factor by groups. So the first group, factor out 3x. We're left with x minus 3. Second group, factor out 1. Again, we're left with x minus 3 as we expect. Same brackets. So common bracket x minus 3. And the other terms outside the bracket, that's 3x plus 1. So to solve, we equate both factors to 0. So equate x minus 3 to 0 would mean x equal to 3. That's 1x coordinate. Equate 3x plus 1 to 0. That means 3x equal to negative 1. Divide both sides by 3. So x equal to negative 1/3. So our two x coordinates of the stationary points is positive 3 and negative 1/3. The nature now, to get the nature, we need the second derivative. So the second derivative, that differentiate g again. So here was the first derivative. Differentiate again, multiply by the x power, subtract 1 from the x power. So 2 times 3, that's 6x. Differentiate negative 8x, that's negative 8. So let's test each point now. So when x equal to 3, the second derivative is 6 times 3 minus 8. So 6 times 3, that's 18. 18 minus 8, that's 10. And 10 is bigger than 0. So when the second derivative is bigger than 0, that's a minimum point. Let's try the other x value now, negative 1/3. So when x equal to negative 1/3, the second derivative, here it is 6 times negative 1/3 and then minus 8. We end up with 6 times negative 1/3, that's negative 2, minus 8, that's negative 10, which is less than 0. When it's less than 0, second derivative, it's a maximum point. Let's move on. The volume of a spherical ball is given by the formula V equal to 4/3 pi r cubed. R is the radius. The ball developed a leak and its volume is decreasing at a rate of 2 centimeter cubed per second. So this is the rate of change of the volume. So dV volume, notice volume over time, cm cube over seconds. And it's a negative decreasing, so it will be negative 2. So we know from now that dV by dt will be negative 2. We have to find dV by dr. Now dV by dr, you're differentiating the volume with respect to r. So you multiply that by the r power. So 3 times 4/3. So 3 times 4/3 pi, and you subtract 1 from the r power. So 3 into 3. So dV by dr is 4 pi r squared. Derive the expression for the rate at which the radius is changing. So dr by dt. So dr by dt. So the expression, so we need dr in the numerator for the first one, and we need dt, and these two must be the same. obviously it has to be dv. Since we're talking about volume, a change of volume. Alright, so that's the expression for dr by dt. And calculate the rate at which the radius is changing when r is 5. So the rate at which the radius is changing is dr by dt, dr by dv times dr by dv by dv. So these must be the same, dv and dt. So dr by dv is 1 over d. So we know dv by dr is 4 pi r squared. So if we put it over 1, if you reciprocate both sides, that means dr by dv is 1 over 4 pi r squared. Just flip both sides. So dr by dv is 1 over 4 pi r squared. And dv by dt we already know is negative 2. Rate of which the volume is changing, negative 2. And we are told now that r is 5. So we're going to substitute 5 for r. So it's 1 over 4 pi times r squared, and r is 5, so times 5 squared times negative 2. So we can simplify this a little bit. So 2 into itself, that's 1. 2 into 4, that's 2. And 5 squared is 25. So in the denominator, we have 5 squared, which is 25, times 2, that's 50. 50 pi. And 1 times negative 1, so negative 1 over 55. And the unit is centimeters per seconds. Determine the following indefinite integral. So we can rewrite this is obviously a reverse chain rule problem. So 4x plus 7 to the power of minus 2. Just bring it up, dx. We apply the integration rule. Add 1 to the power. Add 1 to the power we get. So it's negative 2 plus 1. Negative 2 plus 1. That's negative 1 over, divided by the new power, which is negative 1, times the derivative of the bracket, the constant in the bracket, sorry, the x coefficient in the bracket, or the derivative, that's 4. And remember plus c. And we can also rewrite this as, this is, we can bring it back down. So this is negative 4, 1, so 1 over, bring it back down, the power would become positive, right? 4x plus 7. Well, 4x plus 7 to the positive 1. To the positive 1. That's another way you can rewrite it. Or you can leave it like this, either or either. It doesn't really matter. Alright, part B. Determine the area of the shaded region bounded by the curve and the x-axis. So the curve here, we have the equation here. And the x-axis, is cut the x-axis at 6. And midway between 2 and 4, that's positive 3. Alright, so the area, the formula for area is the integral. In this case, the 2x values. The upper value there is 6. The lower limit there is 3. So we're integrating the function negative x squared plus 9x minus 18 between these two x values. Alright, so let's integrate. So rule, add 1 to the power, divide by the power. So limits are 6 and 3. Add 1 to the power, you get positive 3 and divide by 3. Next one, add 1 to the power, 9x to the power 1. Add 1, you get 2, divide by 2. Differentiate negative 18. That's negative 18x. So now we form two brackets, minus between them. In the first bracket, replace x with the top limit. In the second bracket, replace x with the bottom limit. So it's x cubed. In the first bracket is 6 cubed divided by 3. 9x squared is 9 times 6 squared divided by 2. So it's 9 times 6 squared divided by 2. And minus 18 times 6. In the second bracket, replace x with 3. So it's negative 3 cubed divided by 3 plus 9 times 3 squared over 2. So 9 times 3 squared over 2 and minus 18 times 3. So substitute x, 3 for x, 6 for x in this first, and the bottom limit 3 in the second bracket. Alright, so we just need to use our calculator and assist us now to calculate these brackets. So in the first bracket, we know 6 cubed is negative 216 divided by 3. 6 squared is 36, plus 9 times 6, that's 324 divided by 2, and 18 times 6, that's 108, minus, now 3 cubed is, well, negative 3 cubed is negative 27 divided by 3, so that's negative 9, plus 9 times 3 squared, that's 9 times 9, that's 81 over 2, and 18 times 3, that's 54. Alright, and just enter this in your calculator as it is, and you should get 9 over 2 or 4.5 and it's square units, right? Since it's area, let's move on to part C. The rate of population growth per second for a species of bacteria after an antibacterial solution is introduced is modeled by the differential equation. dP by dt is equal to minus 101.5.1 t to the 0.1 t plus 3. If the initial size of the bacteria population was 10,000 specimens, derive a formula for the population size. So initial size, initial is when t0, when t0, time is 0, that's initial, the population should be 10,000. Alright, so we're going to derive an expression or a formula for P with respect to T. So we have dP by dt. So to get P, we can integrate both sides. So if we integrate both sides, integrate the left hand side, we'll get P with respect to T. So integrate dP by dt, we get P, and integrate the left hand side now, we have minus 101.5 e to the 0.1 t plus 3 to differentiate, to integrate it, sorry. We divide by the t coefficient or the derivative of 0.1 t, which is just 0.1. Plus or a constant, which means that P with respect to time is 101.5 divided by 0.1. That's 1015, negative 1015. E to the 0.1 t plus 3 plus a constant. So we are told now that when t0, p is 10,000. Alright, so we can replace t with 0, so we can substitute t0 for t and 10,000 for p. So replace p with 10,000 and replace t with 0. So we plug these into this. Replace t with 0 with 0.1 times 0, which is 0. So what we have is negative 1015 e to the power of positive 3 plus c. So to get the constant c, we can divide both sides by, so we can group the terms on the left. So we have c, so we have 10,000. We group this over here, we have 1015, positive 1015 times e to the power of 3. And then we put this in our calculator. So we have 10,000 and then 1015 times e to the power of 3. That's 20,386.82 if I'm using 2 decimal places, which means that C, let's find some space to put it, which means that C is 30,386.82. So that's C. Alright, so which means therefore that P, let's separate it. That's C, sorry, that's C. Which means therefore that P with respect to time is equal to negative 1015 e to the power of 0.1 t plus 3 plus c. So we're using this. So let's write it back and we put in the value of c now, since we know it. The value of c is what now? 30,386. So that's plus 30,386.82, right? 0.82. Well, let me write it better down here. So P, right down here, so P, negative 1015 e to the 0.1 t plus 3 plus 30,386.82. And we're asked now to determine the size of the bacteria population after 30 seconds. So we're simply going to replace now t with 30. Alright? So give your answer to 2 decimal places. So we're going to find P of 30, negative 1015 e, and then replacing t with 30. So it's 0.1 times 30, and 0.1 times 30 is 3, plus the 3 other 3 that's here. So that's e to the 6 we'll end up with now, plus 30,386.82, and we'll enter all of this in our calculator, and we should get as our final answer minus 379,093.41. That's the end of our paper.